Hi, folks. Thanks for tuning into my session. Today, I'm going to talk about NVMe over fabrics in the enterprise. My name is Rupin Mohan. I'm a director of R&D at Hewlett Packard Enterprise Storage. So it's a pleasure for me to deliver this seminar, and I'm recording this. So please excuse any gaps that I have. So the agenda for today is I'm going to start the presentation talking about some data center trends and then kind of go back and look at what's happening with NVMe and kind of go through the whole stack and all the changes that are happening in the stack. Then I'll go and talk about in the hybrid cloud, what are the different protocols out there and what kind of works for NVMe over fabrics. And then this is going to be the main thing I'm going to talk about right now today is this whole concept of the NVMe centralized discovery controller for Ethernet fabrics. And then end with some next steps and actions for all you developers out there. So let's talk about data center trends and what we are seeing in the market and with the customers and in the enterprise. So the first big trend that we are seeing is this whole concept of disaggregation, right? What does it really mean? And kind of try to explain it in simple terms. The whole idea about disaggregation, in my opinion, is the idea of our customers kind of looking at new architectures. Traditionally, what we're seeing, is that, our and plenty customers even today are running, your traditional data centers where you have your compute racks, top of rack switches connected to storage arrays, right? What I think the new paradigm or the new way people are looking at deploying, infrastructure is this whole concept of disaggregation, and it's kind of a loaded term, and it involves a lot of different things. So what it really means is, think of a data center with unlimited bandwidth, lots of bandwidth in terms of infrastructure. And it's workload driven, so customers have the ability to move workloads around in the data center depending on their application and the business needs. It's no longer an east-west traffic or north-south. It's kind of like you have bandwidth, where you go in any direction, and you can move applications across broadcast domains, across the data center, wherever you feel the workloads need to be, where your infrastructure is, the right infrastructure is there, right? It's very low latency, it's high IOPS, and a lot of it is actually software defined, right? Which gives customers more sort of flexibility to scale. And then, the whole, idea around orchestration, automation, is big, and we are seeing that customers want to do more with less. Budgets are going down; they're not going up, and customers want more from their IT and more bang for the buck. The whole idea around industry standards, I think, is still extremely important for the enterprise, and that's why we work a lot in standards and SNIA and NVMe group, T11, etc. I mean, so customers definitely want standards. They want to be able to deploy technology that they can have some choice around, and so they don't get locked into some sort of proprietary implementation. So I think standards are important and will continue to be important even in this new world of disaggregation. I think hybrid cloud is another big trend that's kind of related to disaggregation, where customers want to be able to deploy workloads on-prem. They want to be able to move workloads to the cloud and bring them back. Again, they want that flexibility to manage their IT, manage their infrastructure, manage their applications, depending on their business needs, depending on their customers, depending on the budgets. So they do definitely want that capability. And of course, all that buffet of features, at lowest cost of ownership, of course, and they also want great customer experience. So that's kind of the big trend going on in the enterprise and in the industry. The other related topic around trends is that as we all know, storage is hard, it's difficult. What they're also, another trend going on is, while this whole trend of disaggregation is happening, right? Customers are realizing that, they've got a lot of expensive drives kind of siloed, in these individual servers. And it's kind of like back 20 years back when the whole, concept of shared storage kind of came into the market. And, we just created a brand new segment for enterprise storage, shared storage. And I think the same concept is coming back, for this new use case also, where they're saying, hey, I love this concept of disaggregation. I love this concept of being able to move workloads, being able to, be software defined. But I also want to be able to not have to silo all my investments, in the, individual servers. So how can I get that performance and the ease of use of direct attached storage, but yet kind of get the benefit of shared storage? And that's another trend we're seeing, this whole concept of NVMe over Fabrics attached storage, and concept of JBOFs, just a bunch of flash. And I think this is an area where we're going to see a lot of different products and a lot of innovation. And I'm going to talk a lot about that in today's presentation, guys and gals. So those are the two big things I want to talk to you guys about in terms of trends. So let's keep on going. I love this format of, by the way, recording these presentations, because I can really get through the stuff material fairly quickly, and then you guys can also absorb it hopefully, and watch it again if you have to. But we can do more with less again. So the new IO stack is in terms of NVMe over Fabrics, right? So last 20 odd years, right, we've been working on traditional storage arrays, shared storage. Controllers running SCSI protocol, which is more than 20 years old, maybe 30 years old. Front end is Fibre Channel SCSI, back end is SAS SATA, and very rich software rich in terms of features and functionality. What today is, we've already made this transition to hybrid, in my opinion, where you find most of the storage arrays out there in the market are running some sort of hybrid NVMe stack. And this could be, the drives are NVMe, controller still running SCSI, so there's some translation going on. And then you take some advantages of NVMe through memory-driven flash, using storage class memory. These arrays also are very, rich in features, because your traditional software features are running, using SCSI, so you don't need to make a lot of changes to your existing, value-add features. The next generation arrays is what we're going to start seeing, and we are already seeing some of them in the market. And these are arrays that are really running, full NVMe stack, from top to bottom, and back and front end, both NVMe over Fabrics. And although you'll find that the software on these new arrays are going to be, it's going to take some time to mature. This is very good. The analogy I always give to people, and it kind of resonates, is the same concept happened with our engines, right? Starting with gasoline engines, hybrid engines, and now all electric. And it's, instead of 10, 15 years, I mean, this whole journey for NVMe is, I think, going to be shrunk to like 3 years, 2 to 3 years. So you won't see a 10-year journey, but of course, it's a different animal. So in terms of stack, right, starting from applications down to the OS stack, the volume managers, the disk drivers, the mini port drivers, and then going down to your adapters and SAN switches. And then on the other side of the array, you have your host ports, you have storage class memory, and then you have your controllers, your some drives in the head shell, and then you of course have JBOF. So I think from an NVMe perspective, every single layer in the stack has to really mature and take really advantage of the protocol and the capabilities of the protocol. And most of you are well aware of what NVMe offers. I'm not going to go and regurgitate all the advantages of NVMe. Okay, so in terms of applications, they have to take advantage of SPDK, RDMA. The volume managers have to be optimized to the NVMe protocol, which is also a big deal, right? It's not, you can't expect, your old, volume manager designed for SCSI to be really taking advantages of NVMe. So you know, so that's why you find that, you know, in terms of operating system support, right? We have kind of limited operating system support when it comes to NVMe over Fabrics. You know, Linux is of course leading the charge. It's a community effort, and you know, and we have other vendors who have made big announcements, you know, and others will make more announcements, like VMware is also VMware 7.0. So you know, again, the driver stack also has to make a lot of changes, and take advantage of NVMe over Fabrics. And then of course you have the switches. You know, you have Fibre Channel switches as a transport. You have Ethernet switches as a transport. I think Fibre Channel is ahead of the game, you know, in terms of you know, adopting you know, NVMe over Fabrics, because a lot of the things just, you know, I had to kind of work you know, from a protocol perspective. A lot of the features over there, and you know, from a customer perspective, you know, they're taking advantage of the same infrastructure, and all they had to do was basically update the firmware in the switch on their switches to take advantage of FC NVMe. On the storage array side, I think the storage arrays is where the biggest lift, just like the operating systems, will have to take a big lift, and we see great progress being made by all vendors, including HPE, and you know, we're doing a lot of work in this area, and you see that, you know, you know, pretty cool you know, advantages. I'll keep on going. So my next topic is basically, let's talk about, you know, in this NVMe over Fabrics, you know, land, what are the different use cases that we are seeing customers want, you know, to see. So one of the things that, you know, I like to talk about a lot is that, you know, the whole front end and the back end fabrics, right? So again, if you guys are been in the industry for a long time, like I have been, you know, when we started to see Fibre Channel drives, right? And you know, and you had, you know, storage arrays with, you know, FCAL drives, and there was a fabric in the back end of the storage controllers, right? So same thing we're seeing now with NVMe over Fabrics, that, you know, we're seeing that both the front end fabrics has always existed, you know, for shared storage, but you know, even on the back end, you know, we're seeing that storage controllers are taking advantage of the performance advantage of the protocol, and you know, you see across the board that, you know, they're going to take advantage of you know, NVMe over Fabrics on the back end too. So you know, so keep that in mind, where, you know, as the new architectures are being developed. You know, this is a storage developers conference, so you know, we have to talk about what's in development, not just, you know, what's out there. So in terms of use cases, right? I mean, you know, we are seeing, you know, several different use cases. You know, you're seeing, you know, customers want to take advantage of these really high performance drives. So you know, they have, you know, direct connect, you know, use cases, daisy chain use cases, with servers, you know, servers, you know, with RNICs, in some cases SmartNICs. So you know, but on a shared storage side, you know, which we want to focus on in today's presentation, is, you know, we are seeing, you know, two different sort of use cases. One is where you have just a bunch of flash, you know, connected to you know, servers, using some sort of storage fabric, and then, you know, on the last, you know, number 4 use case, you're seeing, you know, your traditional enterprise storage arrays, you know, with storage controllers, and your front end, back end fabrics, you know, with NVMe over Fabrics connected drives. All right, so these are the 4 different use cases we are seeing, and the use case number 3 is sort of, you know, I think, you know, right now really getting very popular also, because you know, especially for the software defined use case, right, where you have you know, a lot of the features, functionality being present in the software defined stacks, scale out storage, you know, where they just want access to a bunch of really high performance, you know, NVMe drives connected over Fabric. So you know, moving really fast, I guess this is how this recording thing works. But let's talk a little bit about hybrid cloud and what are the different protocols. So one of the things people ask me every time I deliver an NVMe quote unquote over Fabrics presentation is, you know, hey, what's your take on all these different protocols, all these different choices I have? And, you know, instead of going, you know, having a the good old SNIA days where we would have protocol wars, where we have this versus that and this versus that presentation. I kind of summarized it in one slide, and I think Fibre Channel, is out there, and it's got a huge install base, millions and millions and millions of ports, and it's a protocol that was designed for storage, and it was designed for shared storage. So I think Fibre Channel continues to remain popular, especially in that tier zero, on-prem tier zero, hybrid enterprise, right? I think the Fibre Channel will continue to remain very popular there, and it does offer pretty high performance. It's quite scalable, and it offers quite low latency. So moving on, in terms of Ethernet, right? I mean, Ethernet, I think Rocky V2 and TCP are the two, sort of competitive protocols, for NVMe fabrics. I think Rocky V2 has definitely the lowest latency. I think a number of you have run some tests, and we have run some tests. I mean, it does offer quite low latency in terms of numbers. So I think that's why it's very attractive. And of course, it's V2, it's scalable, and I believe for a tier zero hybrid enterprise. And hybrid, I mean, hey, workloads being able to move from prem to the cloud and back. I think that's why I think for tier zero hybrid, I think a Rocky V2 will be a very interesting protocol. As far as TCP is concerned, I think TCP can offer pretty low latency also, especially when you have with offload cards, where you can do NVMe offload, TCP offload. I think it'll offer quite low latency, not probably as low as Rocky V2, but quite low. From a scalability perspective, I think this will probably be the most scalable, because it's TCP, and for good or bad, it is very scalable, and the performance can be pretty high, right? Again, if you have offload cards and everything, I think the performance can be fairly good. And I think from a tier one perspective, hybrid cloud perspective, I think this probably will end up to be one of the leading protocols, in the market. As far as InfiniBand is concerned, I think InfiniBand has a use case probably in the back end of the array, maybe. But I think from a front end perspective, front end host fabric that's connected to hosts, I don't think that it's going to have any footprint. So and then from an IWAP perspective, I have kind of similar feelings about that. So I'm just taking a stab in the ground and saying, you're not going to see any InfiniBand and IWAP in the hybrid enterprise when it comes to NVMe fabrics. On the back end, like I said, InfiniBand can be there, and the beauty about in the back end fabric is it's a closed environment, and implementers have that black box kind of an environment where they can do whatever they want and kind of fine tune their their implementation. So it's probably okay, and it probably won't even require any configuration or much configuration because it's kind of automated, orchestrated by the controllers itself. So that's why I think that maybe there is some presence in the backend, but I don't think there's going to be any presence in the backend, in the front end of of the fabric. Moving along, guys and gals. So let me move on to the whole concept of a centralized discovery controller for Ethernet storage fabrics. So we are kind of as an industry, we got together and as part of the NVMe group, right? And figured out that this is a problem that exists, and I'm going to talk more in details about what this problem is all about. And started working on a solution together. I do want to just quickly say that this problem has already been, in Fibre Channel, this problem does not exist because we already have a concept of name server, and we already have a concept of automated discovery, etc. in Fibre Channel. So Fibre Channel, this problem doesn't exist. That's why we kind of calling it a CDC, centralized discovery controller for Ethernet storage fabrics, because that's where the problem exists, and that's what we're working on, and that's what we want to solve. Okay, so really just let's talk about the problem statement here a little bit before we kind of discuss what are the different efforts we're doing to solve this problem. What we are seeing is that when it comes to configuring NVMe-oF fabrics, right? Discovering hosts, discovering subsystems, discovering storage devices, it's kind of a problem, right? And it's very manual. It's very command line sort of intensive, and you have to do some things before you can even figure out where your storage, your discovery controllers are. So we're trying to solve that problem of being able to discover all the hosts and all the storage devices in your fabric. Um, the other problem we're trying to solve is a scalability problem, right? In a small fabric, where you have some servers, some storage devices, it's kind of no problem, right? Because it's easy to discover, easy to configure. We're not, from a scale, as you scale, it becomes a real problem. So that's another area we want to solve, is we want to be able, customers to be able to deploy NVMe over fabrics at scale. Okay, so that's huge for us. It's a huge problem, and we're going to solve it. And the other thing is that there are NVMe-oF fabrics. There's a concept of a discovery controller, and there's no standardized mechanism to share information between these discovery controllers. So again, we want to come out with some standard, industry standard, so folks can work with each other. The next thing that we are trying to attack is the fact that there's no resource visibility management mechanism, right, in NVMe-oF right now for Ethernet. Something like what ISNS did for iSCSI fabrics or Fibre Channel does with zoning. There's no such concept of discovery domains of zoning, in NVMe-oF. That's another area we want to be able to give our customers capabilities to do, things like zoning, et cetera, or discovery domains in ISNS. And then the last thing we are also trying to solve is the being able to generate the fabric to be able to generate some events, and the fabric to be able to handle some of the notifications. The topology changes, grouping changes, in the fabric. I think we want to be able to handle that in an Ethernet storage fabric. So this is a quick list of all the things that we want to be working on. And we have a couple of efforts going on in the NVMe group, and I'll talk about those two technical proposals that are currently in development. So the two proposals that are in development today are TP8009 and TP8010. We have a lot of active members on our weekly calls, working diligently on these two proposals. We have representation from HPE, Dell EMC, NetApp, Intel, Lightbits, Mellanox, Marvell, Samsung, and VMware. So we have pretty much all the companies getting together and trying to solve this problem, and it's a great team effort by the teams, and I applaud that. So quick overview of 8009 and 8010, and then we'll go in a little bit more detail. So 8009 is really an automated discovery mechanism for discovery controllers. 8009 uses existing protocols like MDNS and DNS-SD. So it really does not try to reinvent things that have already been invented, which is pretty cool. So what 8009 gives customers and will give customers the capabilities is that their servers, their hosts will be able to use MDNS query. And the discovery controller will basically respond with its IP address and what type of transport it supports. And it makes it very easy for the servers and the host to connect to that discovery controller. Today that is a manual step process. The other thing that 8009 will give you is that if there is a centralized discovery controller in the fabric, a host or a subsystem can send that query, and the centralized discovery controller will respond. And those details are defined in 8010, TP8010. Okay. What is okay? Before I go to 8010, we want to make sure as a group, as an industry, that existing implementations are not broken and we maintain compatibility. So that makes the job for the engineers even more challenging and more interesting. So TP8010 uses 8009 MDNS mechanism to discover the CDC. The CDC kind of aggregates all the discovery information for all the NVMe fabrics, hosts, and subsystems, and it groups all the information together, and it'll give you the capability to do zoning, and also give you the capability to generate fabric events for any changes in the fabric. So that's kind of the high-level overview for these two proposals, technical proposals under development in the FMDS, which is the Fabric and Multi-Domain Subsystem Group. Moving along, 8009. So as I mentioned before, it uses existing MDNS and DNS-ST protocols defined in RFC 6762 and 6763, and kind of we divided this problem into three different sort of use cases, A, B, and C. The direct connect use case, a single broadcast domain use case, and then a multi broadcast domain use case. And 8009 kind of solves and problems for all the three different use cases, because as I mentioned before, when you have a centralized discovery controller present, it will respond with its IP address and all the protocols and transport it supports. The benefit is, of course, automated discovery. So you don't have to do a lot of manual stuff, which is great. And then also it enables all the entities to discover and detect all the discovery controllers out there coming and going in the fabric. The standard does not preclude folks from designing an HA solution, which we assume most people will. When they implement this type of a solution, it'll have some sort of an HA capability, so that this particular feature does not go away if something goes down. Implementation details, guys, are still in the works, and the work is in progress. So if you want to participate, you can join the group and help develop the technology and how it exactly works. If you're part of the NVMe group, you're a member, and you have access to the information, then you can easily access all the documents that are being developed and the details being developed in this proposal. For TP8010, which is the whole concept of centralized discovery controller, again, this is one of the big things we're working on, and it enables a robust, scalable storage fabric, and it really will help us deploy NVMe-oF fabrics in the hybrid cloud in the enterprise at scale. And it uses mechanisms that were defined in 8009 to discover, for the CDC to be discovered, and CDC will have the capability to aggregate all the discovery information of hosts and subsystems using all the discovery controllers that are present in the fabric. It will support high availability, and again, work is in progress. Just to see the line diagram here. The host and the subsystems will discover, will query for the CDC using TP8009, and the CDC will respond back. Will send the response back with this IP address and what are the transports that are supported. Then there will be, some connectivity information, some configuration option where you will be able to define who gets to see what. But this option will be available after step number 2, which is the host will again register with the CDC, and the subsystems will register with the CDC, and CDC will have a centralized location where it'll have information about all the servers, all the hosts, and all the subsystems in the fabric. Then further along in this whole automated and orchestrated world, hosts will be able to get the log pages from the CDC and be able to directly connect to the NVMe subsystems. Again, this is a very high level view of how this will work. There are lots and lots of details behind this, and if you guys want to help us develop this protocol, you're more than welcome to join the NVMe group if you're not a member already, and you can join the team. We have weekly calls, and would love to see more participation from the industry. So I'm coming to an end with my presentation here. And so what are the key design takeaways for all of you engineers on the call? NVMe-oF Fabric's storage area network, right, offers significant opportunities, right, to lower your latency, service high performance, disaggregated storage architectures. So there's a lot of opportunity because of this this protocol to come up with new architectures, and I'm sure you all are working on that. The hybrid cloud is real, and a hybrid cloud in the enterprise is real and is the future, because I think the cloud is here and it's here to stay. We all recognize that. I think the on-prem is real. That's here to stay. I think customers want flexibility, right? Customers want flexibility, and they want to be able to move workloads around the enterprise on-prem. They want to be able to move some workloads to the cloud and back as needed, and they want that flexibility. So from a protocol perspective, we believe that NVMe Fabrics has all the has great options for the hybrid cloud, for deployment. Again, performance is of course name of the game. That's the name of the game. Guys, in this new NVMe world, I mean, it's a fact. I always tell people, we storage guys are great at absorbing all the performance the protocols can offer us. We will take advantage and advantage of all that, and customers will still demand for more. I'm yet to find a customer who says I have all the performance when I all the IOPS I need, and I'm very happy. Everybody wants more, right? As soon as you satisfy a customer with an implementation and architecture, they get delighted with it, but very soon they want more. So that's the beauty of customers, which I love. Ethernet storage fabric, I think, also is where the enterprise and the cloud intersect. So for the hybrid cloud, I think ESF is going to be very popular because it kind of transcends on-prem and cloud. The last point I want to mention is the whole TP 8009 8010. The discovery of discovery controllers and the ease of discovering discovery controllers, and the whole concept of centralized discovery controller. I think it's really going to help us simplify the deployment and management of NVMe over Ethernet fabrics. And I think those are noble efforts going on in the industry. I really want to congratulate and thank all the engineers working on these two efforts, on these two technical proposals, and I hope to see products out in the industry soon, with implementations and once these standards are published. So thank you, folks, for tuning in today, and I'll be happy to get some questions from you and answer them. I do want to take some time to thank Babu and Curtis in HPE on my team for really working hard and diligently in driving this work in the NVMe standard. I just have the blessings of working with a great team like Babu and Curtis and others at HPE. So thank you guys for helping us out in developing and driving this technology. And thanks again, folks, for tuning in. Thank you.